what I've done here is I've gone and added on just a separate in parallel an encoder. So there's an encoder here, which is not at all involved in the training of the GAN. And what it's doing is it's taking this source image on the left, and it's encoding that into some Z space, and then running that into the GAN generator, and this is the output. Then what's happening is this generated image on the right is being compared to the actual one, and that's how the loss is calculated, mean squared error for the encoder. And that's separate from the GAN. The GAN is doing non-saturating loss. So it's showing epoch and step here, and then you've got the loss for the GAN components, and then the encoder is also shown here. These loss numbers are going to bounce around. The encoder will gradually decrease. And then you can see the different parameters, the weights and the bias for the generator, the discriminator, and the encoder. And what we can do is we can just start to step through this. You know, we see here's a t-shirt coming in. By the way, this is the MNIST fashion data set. It's a bunch of 28 by 28 images with one channel, grayscale, and I'm using that print ASCII function to just visualize them in the terminal here. But as we start stepping through this one by one, not much has happened yet, but you know, some of the model parameters are changing. What I can do is I can change this interval to 10. So we're stepping through 10 at a time. And now what we're seeing is, okay, starting to see some shapes come out of the fog on the right. And you can see how they're not completely random. They are based on some encoding of that source image on the left. Hit S and just let this thing continue on autopilot here, and we can watch it learn. So I thought this, again, was like an interesting hack, because I was sitting here and working with what I had from the GAN. I was having just random images on the left, and I'm like, how can I have this be meaningful? How can I have, you know, how can I compare like an actual image to the generated image? You know, it had to be the same type of thing, and that's why I went down this path of, all right, well, let's just encode it and see if we can make a connection that way. So while that's going, if you're interested, this print ASCII image is on the Datawaza library, which you can go to datawaza.com, and it's also on GitHub there. If you go, you'll see here's this advertisement for the image here, and it's also explained in this user guide. It shows you know, exactly how to use it. You can use it with different types of data, right? Whether it's continuous data or binary data, and yeah. So let's go take a look at this, and we can see that still learning, I guess, but starting to look similar. So the encoder loss is going down nicely. As we know, the GAN loss kind of tends to oscillate. I haven't been paying too much attention to those numbers, but yeah, it doesn't seem to be a smooth trajectory down. That's to be expected. So there you go. If you have any questions, leave me a comment. Yeah, hopefully this was informative. I certainly enjoy visualizing this stuff instead of just staring at the math formulas.